What comes next? What comes later? My Vans shoes match this Vans paper. Ready. We've already seen problems like this. I don't even really want to do this stuff, but well, I want to do it, but we've already done it. So you should already know how to do it. Recall, we can get a hold of our common ratio. We take whatever's coming down next. So the next divided by the current. So why do I say next? Why do I say current? If your current was 2, you could just easily see 4 and not have to do any arithmetic. Whereas if you're saying that your current was back here, you have to find that. So that's why I kind of stick to this notation. I hope that's okay with you. Does it matter really which one's the current, which one's the previous? No, and I'll even show. So common ratio here could say 16/8. It could also be 8/4. It could also be what? What do you think? Could also be 4/2, which is really just +2. So what does this mean? It means that every time this moves forward, it's multiplying by 2. If you're not convinced, try it out. Take a moment, try 2. Try 2. Actually, you know what? Try 2 and 4. This will be good practice. Get these done out of the way. You should have gotten 3. Every time you move forward, it's multiplying by 3. For problem 4, every time you move forward, it is multiplying by 1/4 or 1/4. Or if you really want to get crazy, 0.25. It's another way you could write it, but I would stick with the fraction. Don't be afraid of them. They're cool. We've already seen problems like this, so this should be in the process of becoming, fingers crossed, second nature, or something you just naturally know how to proceed with. If not the equations, at least the sequence. So we'll eventually talk about what type of sequence it is. For right now, I'll just say A or G. Maybe you remember what those are. What's happening with the sequence? Looks as if it just keeps adding 3. Lo and behold, that's the case, making this 24 and this 27. Rest in peace, Kurt Cobain. This kept adding over and over. So A, why did I write A? Because that deals with arithmetic sequences where it's either adding or subtracting every time it moves forward. Maybe we'll see one for G in a second. Recursive, we need to start somewhere. Let's start at the first term, which was just 15. So remember, it's a 2-piece. We need that one where we're starting, our starting value, if you will. Starting value, because you got to start somewhere. If we're starting at 100 and then doubling or adding 3, it's a lot different than starting at 15. You know what I mean? How's this continuing? So notice, this is y, this is x. If I call this f of x, I hope you're okay with that. So f of x equals previous f of x minus 1, just +3. 1-2 punch, easy enough. Explicit, we're starting somewhere. We're starting with 15, and we keep adding 3 and x minus 1 times. Because x is our variable here, x is our input as seen here, and this all equals f of x. You know what? Switch it up. Could call it f of x, but I'm going to call it y. So this works if it's the first term, so term 1. So this would be the explicit if you're talking about where x is 1. Maybe take a moment, practice this, try to go to the 0 term and make that equation. I think you could do it. You have 2 ways you could have expressed this. If you go back to the 0 term, deducting 3 from 15, that gets you 12. So starting at 12, you add 3 just x times, again, because x equals 0 here. If you want to rearrange that, 3x plus 12 equals y's. Good. Hope that works for everybody. Pause it. If you're missing something, let me know. So let's look at 7. You would be foolish. You'd be wild if you kept saying that this kept adding 6, because there's no way it does. 9 plus 6 doesn't get you 27. So let's start fresh. Let's think. If we're going from 3 to 9, we could multiply it by 3, right? 3 times 3 gets you 9. So if this kept going, does 9 times 3 get you 27? Sure does. So we could keep this momentum going. We keep multiplying by 3, pause the video, take a moment, fill in these other 2 numbers for where x is 4 and x is 5. Use a calculator if you need to. Your other 2 terms are here. The type of sequence, we've said previously, the real G's multiply their money. And in this case, we're multiplying by 3. So this is a geometric sequence. Capiche? The recursive, we got to start somewhere. So let's start where it's the first term in the sequence, where x is 1. Well, that's 3. And as this continues, you know what? Yeah, I'll do the wording. So if we're talking about the current term, this is really just the previous times what? What do you think? It's really just times 3, okay? So using the function notation, you could say that f of x equals f of x minus 1 times 3. Previously, we were just using the words to talk about recursive equations. It's still nice. It's still lovely. It's a wonderful way to help you get started making these recursive equations happen. But now a real solid answer, something that is Cortez approved. Cortez approved. Cortez approved. All right, it's not stamping. That's fine. I get it, Adobe. Something that's approved by me, really solid, seen here. There you go. The explicit, you're still starting with 3, keeps multiplying by 3, and this happens x minus 1 times. If you want to go wild, this is when x is 1. If you want to go wild and go crazy and really crush what we're doing here, think about what the x equals 0 explicit could look like. You can backtrack, divide by 3. 3 divided by 3 is just 1. So starting at 1, we keep multiplying by 3, x times, and that equals y. So you have 2 ways you could write this. Actually, you have more if you want to, but these 2 are probably going to be the more common answers that we come across. Capiche? If this whole video just felt like a review, that's a good thing. If it felt as if it was foreign, please talk to me. Please look back at things that we've done so far. Everything here should look and sound familiar. So I hope that this video was more of a refresher than anything. I hope you thought it was helpful. If you're stuck on anything, reach out. Thanks for watching. Thank you for your hard work. Talk soon.